Hey guys and gals, hello again. Welcome. Thank you for hitting the play button. Whoever you are, wherever you are, so awesome of you to do that. I appreciate you. Learning and growing, I love that. Parents, here to support you. Those of you parents that are homeschooling your child, I support you 100% in your decision. I do understand why. So with that said, hopefully, a lot of this, I enjoy mathematics, so a lot of this I'm doing to help support you as a parent or parents. If you're, for those that are homeschooling their children or child, here to help. The reason, I guess, is I don't know how much is on your plate. So I imagine maybe you probably could feel overwhelmed or such. So here to help. Also, students. Any students are also welcome. If you are in public school or whatever. Maybe you're searching YouTube for additional support and help, because you may or may not, I'm not 100% certain, you may just have a not so good instructor, so that's why you're searching for additional help, because you want to succeed. And again, I support you because I want you to succeed as well. Let's go! Turn that up. Okay, I'm quickly going to check the channel. I'm sure we're fine to succeed as... Yes, we are. Let's go. All right. Quick coffee, and then we're going to get going. So let's continue, guys. We are currently working on measures of area. Technically speaking, we're working on Unit 3. It's all mathematics. So whichever order, I guess it doesn't really matter. Okay, let's continue. We are working on some kind of word problems and such. Just clean up the old whiteboard here. It's a whiteboard, so that's what it's going to be, because that's what they use in school. And I don't have a chalkboard, so I'm not going to write on my screen with chalk. That was a drum roll. Okay, let's continue. We're going to work on triangles again. Let's see. Okay, I don't need this anymore. Triangles. Quickly. Triangles. Let's look at triangles. Let's see. Here we go. Okay. Now I know we're not using this formula yet, guys. So, this is just an additional formula that's used for right triangles. Okay? Right triangles. I know I don't really need to show you this, but just to, lead into it, so that you're familiar with seeing the formula and it doesn't scare you or anything when we're actually using it. I always look at the horizontal as X and the vertical as Y. Now, it's okay to name your, this should have been base height. That's okay. Whatever variable you use, it doesn't really matter, guys and gals, okay? Substitution is substitution. The final answer being correct, that's all that matters. Okay? So for me, this is X, this is Y, or you'll also see base and height. And this is what's called the hypotenuse of a triangle. So just to familiarize yourself with the terminology, that's all. We will talk about it in the future. So we're working on basic area calculations. Volume is 3 dimensions. We're working on a 2D plane, X and Y. The formula for a triangle is right here. Here's the base, here's the height. Even if you're just working with a right triangle, it would still be base height. Okay? The other triangles that you have that you may or may not work with are, we're just kind of going over terminology and such again, guys and gals. Okay? Let me find what I'm looking for. Right here. Okay? Equilateral triangles where all sides are the same or equal. Isosceles, the vertical, wow, these sides of the triangle are the same. And then you got scalene, all sides are not equal. And then interior angles, right triangle, you have a 90 degree always on a corner. If it doesn't have a 90 degree interior corner, then it's not a right triangle. Okay, and then you have acute triangle because they're handsome or beautiful triangles. They have angles less than 90 degrees. And then you have oblique, which is greater than 90 degrees. Okay, just to familiarize yourselves. So we are going to work on, so let's just start drawing. So I'm going to draw a vertical line, and then I'm going to draw, fix that, just going with random, whoops. Oh, that was kind of a good line too. It's too long. Too long. That's good. Okay, there we go. There's a right triangle. I'm going to leave that. Okay, I could go like this. Maybe I'll go like this and like this. There we go. And then we have another triangle that's kind of like this. We'll just exaggerate it a little bit so you can clearly tell. Okay, there we go. Okay, so the information we're given is 4. And our units, feet. Okay, and then we're also given this, which is 6. It's a little exaggerated, but we'll just work with it. Okay? So it's asking us to calculate we don't really know this distance here, right? That's the thing. The only knowns that are given is this would actually be like, we could actually pretend this is maybe 3. That would be a 3, 4, 5 triangle, which is a perfect triangle. But we're just going to, so what we're going to be doing is we're going to be calculating the area of this whole triangle here. Okay, guys? Really, that's all we can do because we're not really given any other information. We don't know this distance. It's unknown, and we can't really assume it, right? If we were given at least one more dimension, we'd be able to calculate the area of this one and the area of this one. Or we could calculate the total area and then calculate the area of one of these triangles. Doesn't really matter. And then you just subtract the one from the other. You should subtract from the total, and that would give you the area of the remaining triangle, right? So let's just work with what we have. We're just gonna call it area T, okay? Which is everything, okay, guys? It's gonna be the total area because of this distance right here, okay? And that's gonna equal to base times height. I like to write it like this. It's a lot simpler and easier on the mind, and then it's also written right there. Okay, it's multiplication, so essentially you're doing the same thing anyways. Okay, let's substitute. Worry about that later. Base, this is base, and this is our height, which is 6 times 4, all divided by 2. Again, we could just do factoring, so I'm just going to go like this. I'm going to use 2 as our common number, and I'll just show the work. This is called factoring. We're pulling out as much meat off the bone, and this is the meat off the bone right here. Okay, we're working with these two values right here. So what goes in, what times 2 gives us 2? That is 1. What times 2 gives us 6? That is 3. And then we're left with 4 because 4 is just hanging out and untouched. Okay? Carrying my work forward. These cancel because 2 divided by 2 equals 1. Okay? We're left with 3 times 4 all over 1, which equals 12. Our units are feet, therefore our answer is feet squared. I kind of ran out of room. I'm utilizing all the space, I guess, guys and gals. Hope you don't mind. Just making sure you can see it clearly and there's no problems. Okay? 12 feet squared, guys. Alright, let's continue. Trying to be a little bit more serious, get some work done. Again, the more I do here, the better I'm going to get at this, especially with the drawing. Hopefully it gets better. I want to draw a line. I was doing pretty good too. Okay, Good enough. There we go. Okay, what's next? Explain how the formula for the area of a squared is related to the area of... Okay, so it's kind of going... So we're going to go like this. This is what my son has, and it's pretty intelligent how he did his answer. So, that was a little long, but... Okay, we got a square, and we got a rectangle. Okay. Okay. So, technically speaking, we can call this S1. I'll just write it here. We can call that S2. There's still sides. This is still S1. And this is still S2. Okay? Or we could call it 3 and 4. Doesn't matter, there's still sides. So basically the question is, explain how the formula for the area of A of a square equals S squared, okay, is related to the area of a rectangle which is equal L times W. Okay, in a square, the sides are all equal in length, which is true. Okay, called side S. Okay, the area formula for a rectangle becomes, basically, if we wanted to, we could substitute L equals S1 and W equals S2. And then, so we're left with AR is equal to, because we're substituting new variables, S1. I could drop these. They're just subscripts, but it really doesn't matter. It doesn't affect what these are. Okay, so final answer really turns out to be area R. I'm just gonna go like this. Okay, to carry on. Whoops. S squared. Because S times S. The subscripts really is just identifying this as the first S and this is the second S, but it doesn't really matter because the side, it still works out. You drop the subscripts and they still become, they kind of become one, so it becomes S squared. Subscripts are not the same as this exponent, okay? Just to let you know. I'm going to drop these so that to lessen the confusion. Okay? They just identify this as side 1, this is side 2. That's all it is. Okay? They're not exponents. Okay, that's basically it, which I've showed here. Side times side, which equals side squared. Alright. Let's clean it up. Sometimes you'll have, word problems like that kind of want you to give logical answers, I guess. Okay. All right, here we go. In baseball, I'm going to try to do some drawing. We'll see how well it turns out. I think I'm getting a little tired already. So a pitcher must throw a ball over home plate, okay? So we've already kind of drawn, right? I'm just gonna roughly draw really quick. So you have the pitcher, right? Here's second, here's first. The batter could be on whichever side. You got the ump. So the batter will be either here or here. Okay. And this is going to be 3. Okay. So a pitcher must throw a ball over home plate, right? This being home plate. This is home plate right there. Okay. And between the batter's armpits and knees for the ball. Okay, so I'm going to try to draw a player. It's not going to be perfect, guys, but I'm going to try. Yeah, I guess that kind of works. I don't know. Okay. Of course, they have their arms up. And they would be holding the bat, which is kind of like that. And then the bat is going to be kind of like that, right? And then from, it looks like around the neck area and the knees, I'm just going to kind of go like that. Okay. All right, good enough. This area here, and then of course this is the ground, right? Okay. So, I'm just gonna go B here. No, that's wrong. Z, W, and L. Okay. This is the. I'm just gonna go like this. Okay. Just draw something here for you. Bear with me. I'm trying to be fast here, but I guess slower is quicker. Okay, strike zone. Okay, and so our values, W, what's given, right? These are our given. Just gonna get rid of it. 43, it kind of seems like weird numbers, but 43 centimeters? There's no shot. That doesn't seem realistic to me. But we'll just do them anyways. Okay. That's not realistic at all. Not realistic at all. What are the dimensions of a strike zone? We're going to change dimensions of a strike zone. Let's make this more realistic. What do they have? Okay. So I'm just going to kind of go with what they have. I'm getting rid of these because they just seem redonk. Didn't mean for things to take longer, guys. Okay. So there's a buffer zone too, so technically speaking they have an outside buffer zone which is 2 inches. Okay, 2 inches. Okay, that's this buffer zone here. Okay, it's crude, but you get the idea. So they're saying W is 17. This is more realistic. 17 inches. And 17 inches for W. And what's the vertical? I don't see a vertical at all here. AB. Let me just see if they give me. They don't have any numbers in the let's see. Okay, this is terrible. All I see is the horizontal values. That's it. Okay, I'm gonna see if I can find something else. Midpoint between the batter's shoulders and the top of their uniform pants. So, I mean, I guess it probably depends on the player. The maximum allowable tolerance for a baseball is 2.94 inches. Oh, okay, there we go. Now I kind of have some. Is that the ground? What is that? I got, there we go. 25. We'll just roll with this, okay? I'll roll with this. 0.79. I think that's it. We just need some values, something kind of realistic. So, and that's not including the buffer zone, okay? That's L, remember? The max height is 44.8 inches. That's maximum height. Minimum height, so around the kneecaps, is around 18.29. Like, I don't know why it's that accurate. Nobody's holding a measuring tape. So 18 inches, close enough. I don't even know why we're going with this, right? I should just make it, let's see, 44 take away 18. That's going to be the number. 44 minus 18. 26. Okay? That's what we're going with. Whoops. I'm just going to erase this. Okay? We're going to, because let's be real. Who's holding a measuring tape? There's no measuring tape in the world that you can measure to tenths, hundredths of an inch. Okay? And I don't know too many refs, or I mean umpires that are holding calipers. Okay? Oh, I forgot to continue here. Okay, so that's what we're going with. Whoops. Okay. Now, I know that kind of wasted a little bit of time, but I just wanted to make it more realistic. Okay? Well, I hope you appreciate that. Okay, so the actual maximum height here, yeah, so just so you guys know, I'm just gonna go like this so you have some ideas. This is 18, and then from here to here is our 26. Okay? All right? That's realistic. So I know it's a crude drawing, but I think you get the idea. All right, so let's continue. Okay, let me read again. So in baseball, a pitcher must throw a ball over home plate and between the batter's armpits and knees for the ball to be a strike. This is called the strike zone. Find the strike zone area for the player shown. Okay, there we go. Okay, we don't need to worry about this is 18 inches off the ground to roughly the knees. And L is 26 inches. Our width is 17 inches. Okay, that's more realistic because, you know, I'm pretty sure that's what the umpire is using in his head, right? Okay, so area, we're just going to call it SZ, strike zone, equals length times width, which equals length 26 multiplied by 17. That's substitution. Remember, guys, we're multiplying inches times inches, which equals, guess I could do the long work and I'll just double check with my calculator. 26. I'm thinking maybe I might need a little bit more room. We'll see. Seven times 6, 42. Carry the 4. 7 times 2 is 14. Plus 4, 182. Now you need a place filler because you're going to the tens place now. Place filler, 1 times 6. 6, 2, this is gone now. 2 times 1, 2. Okay, running out of room here, but we should have 2, 8, 9, 10, 11, 12, 13, 14. I always count in threes. 8, 9, 10, 11, 12, 13, 14. Put the 4 down. Carry the 1. 2 plus 1 plus 1. 442 inches squared. And I'm going to go like this. Area. Strike zone. Okay, let me double check. 26 times 17, 442. Let's go! I'm not scared to do long division, and I'm not really saying anything bad. I think personally doing this kind of stuff is great for your mind. Those that are resisting when they're younger to do this kind of work, and they just fill their mind with useless drama and useless information. Personally, I think they're the ones that are going to have Alzheimer's and such when they're older. So they're doing more harm to themselves than good, as far as I'm concerned. This is good for your mind. Keeping your mind fresh, boys and girls. Keeping your mind fresh. Now, I know I may be a little wacky and stuff some days, but I think it's still there. All right, I hope you enjoyed that. That is it for that, because I think we are past the half-an-hour mark. We are. Okay, the next one was a triangle one. Number 3. Oh, yeah. Yeah, that was just silly. We changed it up here. If you understand millimeters, centimeters, yeah, there's no shot. Okay, I don't know. Weird numbers they gave. We made it realistic. So there you go. Strike zone is 442 inches squared. Let's go. That's it, guys and gals. That is it. Another fun stream of excitement. Mathematics excitement. You know you love it. You know you love it. All right, turn it up. Math is fun, guys. Math is fun. Just numbers. Just numbers. Johnny with Whiskey Tango Sharp. Coding and mathematics. Mix of everything. I appreciate you watching. Support you in your, math journey. Keep pushing, keep grinding, guys, gals. Okay, don't look at it as pain. It's wonderfulness. That's what it is. Okay. Parents, students, appreciate you. I will see you guys and gals in the next video. For now, take care. Yeah, see you next video. Peace out. Peace.